Let's spend some time now looking at some harder cases of domain and studying the vertical line test. All right, remember, there are three rules, three cases for domain. If you have an expression under a radical, then the expression cannot be negative, but it can be 0. So it has to be greater than or equal to 0. So you make an algebra problem. What's the problem with denominators? If you have an expression in the denominator, do you remember what has to happen? It cannot equal, that's right, a 0. Now, if your expression is in the radical and in the denominator, then a couple of things need to happen. He can't be negative because he's in a radical, and he can't be 0 because he's in the bottom. So the only thing that's left is positives. So you write a mathematical problem that says greater than 0. Okay, so let's take a look at a couple of problems here that have a lot of stuff going on. This first example here, I noticed that there's a radical. Oh, but wait a minute, I also noticed that there's a denominator. So should I consider the radical expression or the denominator expression? And the answer is both. Okay, so let's take a look at the first one. X minus 9 is under a radical. That's in the numerator, so we're going to be greater than or equal to 0. But the denominator, that expression there, since he's in the bottom, cannot equal 0. So let's solve these two little problems. X has to be greater than or equal to a 9. X cannot equal 24. Okay, now let's take a look at a picture just to make sure we understand what's going on here. So here's a number line. Here's the number 9. Here's the number 24. So I'm saying that I have to be greater than or equal to a 9. I'm going to go greater, 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 but wait a minute. You cannot equal 24. So I'm going to make that be an open bubble, but then greater, 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 greater like that. So I think we're going to say it just like that. X has to be greater than or equal to 9, except do not let X equal a 24. Okay, I like to draw a number line, a picture here, because if this number is way over here, then I wouldn't have to state that, because I would just say use the numbers more than 9. Okay, so we're going to kind of go over some of our algebra here a little bit. Okay, the next thing that we're going to do is consider a quadratic that's in a radical. X squared minus 16 is in a radical. So he has to be greater than or equal to a 0. Now, this is an inequality. Inequalities have some different rules than equal signs. Okay, and I'm going to use a red pen here to write this. We do not square root with inequalities. We do not square root with inequalities. So we're not going to move that 16 over and square root it. Let me just show you the silliness of that. So just kind of watch for a second on this little piece of paper. If I were to take the 16 and switch sides and try to square root, this is what some people say. They say x has to be more than a plus minus 4. And I don't know what in the world this means. If this is a negative 4 and this is a positive 4, so you want me to be greater than a positive 4, but greater than a negative 4? What do you mean greater, greater? How can it be more than him and more than him? Well, that certainly isn't going to make sense. And if I test the number 0, is 0 minus 16 more than a 0? That's not even true. That's not correct. So we do not square root with inequalities. Okay, then what do we do? And the answer is always factor. We factor. So let's go ahead and factor that into x plus 4, x minus 4, greater than or equal to 0. Step 1. Now, some people are thinking, well, aren't we getting plus and minus 4 again? Yes. But what we do is we draw a number line. So we're going to draw a number line, and we're going to put plus and minus 4 on it. There's negative 4, there's positive 4. Okay. Now let's test, number 3, let's test the number line. Test the sections. Test the sections so we can figure out where the answer is. Okay, first of all, is 4 a good answer? If I put 4 into the problem, 4 times 4 is 16, but 16 minus 16 makes a 0. Do we want to equal a 0? In this case, we do. So this is going to be a good answer, and this is going to be a good answer. Those numbers are what make the 0. And in this case, we want to equal 0. Okay, now we have to test these 3 sections. The first number I'm going to test is 0. Is 0 a good answer? Is 0 minus 16 positive? No, that section is not good. How about a number here? Let's try a 10. Is 10 squared 100 minus 16 going to be more than 0? And the answer is yes. That's a good section. All those numbers are going to work. How about negative 10? A negative 10 squared makes positive 100. That's going to be a good section too. Okay, so let's go ahead and officially, number 4, state the answer. Let's state the answer. So I've got from, let's see, x is less than or equal to negative 4. And then this section, x is greater than or equal to a 4. So I've got those 2 sections right there. Okay, so that's some Algebra 2 review. You cannot square root with inequalities. We have to draw a number line and test the sections because we don't want to end up with icky stuff like this that says greater than plus minus a 4. You can't be greater than a plus minus. That doesn't make sense. Okay, here we go again. I see an expression under a radical, so 25 minus x squared has to be greater than or equal to 0. Remember, we do not square root with inequalities. Okay, do not square root. It's not an equal sign. So step 1, we factor. Factor, factor, factor. Now, if the 25 is first, you need to put the 5 first. And if the x squared is last, we'll put him last. And this seems to be a difference of squares, so plus and minus 5. Okay, number 2, draw a number line. So what numbers are going to go on this number line? And the answer is plus minus 5. Okay, step 3, test the sections. So let's look at these. Do I want to equal a 5? And you look at the inequality sign, it says equal to. If I plug in a 5, that makes a 0. These are the zeros. And I do want to equal them, so these are going to be closed bubbles this time. Okay, let's test the number 0. Is 25 minus 0 more than 0? Yes. Okay, so this is a good section. Let's test the number 10. Is 25 minus 100 positive? No, that section's not good. And the same thing with negative 10. 25 minus negative 10 times negative 10 is 100. 25 minus 100 is not any good. Okay, so the answer is negative 5 less than or equal to x, less than or equal to 5. Okay, whenever you have it in the middle, you're going to write it as a sandwich. And there's a couple things you have to remember from your algebra class. Always use less than or equal to signs. Okay, they're always the same. Always use those signs, and they must match. We're not going to do a less than greater. That does not make sense. And then you always do small up to big. Negative 5 is less than x, which is less than 5. So it looks just like the number line, small to big. And you always use less than signs because it goes small to big. Okay, these are some interesting ones. So domain along with some algebra skills. All right, letter D here. Letter D. Numerator, no problem, but I see a denominator. The absolute value of 2x plus 3 minus 7, that's the denominator, cannot equal a 0. Now we're going to have to refresh our absolute value knowledge. So the first thing I'll do is move the 7 over. And you cannot equal a 7. All right, algebra people. I want to get rid of these absolute value signs, but you can't just make them go away. How do we solve absolute value equations? Okay, and the answer is you make two equations. You make two equations. Okay, so you take the expression inside, 2x plus 3. 2x plus 3. You make two equations. Where's my purple pen? One here, one here. And we're going to say cannot equal. Okay, so far there's really no difference. How am I making two equations? So the first answer is do not be a 7. And the second answer is do not be, that's right, a negative 7. And then we'll just solve from here. We'll just solve from here. So let's see. Let's subtract 3. Minus 3 minus 3 is a 4. Divide by 2. X cannot equal 2. All right, let's solve this one over here. Let's minus 3 minus 2, that's negative 10. X cannot equal negative 5. Now, not equal signs are like equal signs. You could square root them, you could divide, no problem. Okay, a lot of these other examples were inequality signs. So what is the answer for this problem? The domain is all reals, except there's two numbers you can't be. X cannot be a 2, and X cannot be negative 5. Those two numbers are going to give us a problem. Really? Well, you could check and see. You could take 2, and you could plug it into the problem. 2 times 2 is 4. 4 plus 3 is 7. The absolute value of 7 is 7 minus 7. Uh-oh. If I tried plugging 2 in, that would make the bottom 0. And remember, that makes it undefined. If you have a number down there, a number divided by 0, undefined. So do not let anybody plug a 2 into that problem. Okay, let's see. I think we've got a couple more here. A couple more where there's two cases. Okay, so letter E. I see a radical. What's wrong with radicals? They don't like negatives. You could put 0 into that one. So greater than or equal to 0. X is greater than or equal to negative 3. But wait a minute, there's also a denominator to consider. Okay, so here's another equation for us. The denominator cannot be a 0. Do I have to factor this one? Make a number line? No, it's an equal sign. Equal signs, you can just simply move it over and square root. But don't forget, when you square root, you cannot be plus or minus 6. Okay, now I kind of want to put this all together on a number line to see what's going on. Okay, so let's put the numbers negative 6, negative 3, positive 6. Okay, so this part right here says do not be a negative 6, do not be a positive 6. You can't use those numbers. But this part here says you have to be equal to negative 3 or greater. Greater, greater, greater. So what's the domain for this one? The domain is x's have to be greater than or equal to negative 3. So you're only allowed to use these numbers. Oh, except, comma, except, don't use the number 6. The question is, should I tell people, hey people, don't use negative 6? No, that would be redundant because I already said you're only allowed to use these numbers. So should I tell everyone, hey, don't use negative 6? Don't worry, I wasn't planning on it. Hey, don't use negative 7. I'm not. I'm using negative 3 on. Okay, so we don't want to be redundant and say don't use any of these numbers because I already said that right here when I said only use numbers more than negative 3. So I'm just going to put a little note here. Do not be redundant. Okay, and drawing a number line picture helps you realize what you need to say and what you don't need to say. Okay, the last domain problem. I see an expression under a radical. Radical in the numerator wants us to be greater than or equal to 0. I see an inequality, people. So should I move over the x or the 4? Neither. You're not allowed to square root. So what are the steps? Go back to the last page and check them out. Step 1, we're going to factor. Now let's make sure we factor this correctly. The 4's first, so put the number first. Put the 2's first. And then difference of squares, plus x minus x. Okay, after you factor, what's the next step? Draw a number line. And the numbers that go on here are, obviously, the 2's. Can I equal the 2's in this case? Yes, you can equal them. It says equal. Equal. Now I have to figure out if it's more than 2, between them, or less, or where the answers are. What numbers are going to work? So let's test the number 0. Is 4 minus 0 more than 0? Yes, that's a good section. So colored in. I need to see number line. This is where you figure out the answer. Without number line, without shading, you're not showing all the work. Okay, let's try the number, I don't know, I always pick 10. 4 minus 100. Well, that's not going to be more than 0. Nope, that's not a good section. Negative 10, same thing, not a good section. So where's the answer? Where's the domain? You are only allowed to plug in numbers that are negative 2, less than or equal to x, less than or equal all the way as high as positive 2. Remember, these are always less than signs. That's how you write a sandwich. Okay, so those are some harder domain problems with a lot of algebra review. The last thing we're going to look at here is the vertical line test. The vertical line test is very easy to perform, and it tells us if a graph is a function. It tells us if a graph is a function. The vertical line test says if a vertical line intersects a graph, so if it intersects the graph, comma, then it only intersects in one point. If it intersects. So if there doesn't happen to be any graph, that's okay. But if it touches graph, it can only touch in one point. Okay, how do we perform the vertical line test? Okay, this is very easy, guys. Just make sure you show your work. Okay, you draw vertical lines. So please don't turn in your test or quiz without any lines, because then I don't know if you know about this test. So you take a look at the graph. You draw vertical lines, nice and straight, and every line that touches, it should only touch once. Is this graph a function? Yes. Okay, here's another graph. Here's a cubic. Every vertical line I draw, does it only touch once? Then yes. Okay, please draw these lines. I need to see your vertical line testing. Here, there's no graph, so that doesn't count. Here it only touches once, but here it touches twice. Uh-oh, 2 touches. This is not a function. It's failing the test. That's a nice graph. It's a parabola opening to the right, but it's not a function. Is a circle a function? No, not a function. Okay, the last one here says, is this a function? And I'm going to use my graphing calculator to get a nice graph. But first, we have to make this y equals. So we're going to have to square root both sides. And y equals the square root of the quantity x plus 4. But wait a minute, that's not right. Not right. You know what I forgot? I forgot plus and minus. I know that we've done something like this before. There is no plus minus button in the calculator, so we're going to have to type how many equations? 2 equations. We're going to have to type y equals the positive square root of x plus 4 and then negative square root of x plus 4. So let's go ahead and take out our calculators and clear out all your equations that you might have. The first equation is the square root of x plus 4. And the second one is the negative square root of x plus 4. I think I'm going to try to zoom standard, see if that's the entire graph. Oh, it's looking really good. So there's the first one. There's the second one. Okay, so let's draw a nice graph here on our paper. Oh, you know what I would really like to know is where to start this thing. What is that point right there? We could take a guess, and then we could check by hitting trace. What do you think that number is? Negative. Okay, let's try negative 4. Yes, so negative 4 is where it starts. We've got one arch going up, one arch going down. Now that you have a really nice graph drawn on your paper, please perform the vertical line test. Here I go. Line, line, line. As soon as one of those lines touches 2 times, you can answer this question. Okay? It is not a function. So of the 2 things that we learned today, I think you guys can determine if a graph is a function by using the vertical line test. So solving the domain algebraically is what we're going to have to do a lot of practice on tomorrow.